Okay. So we're just gonna start from the beginning. When I do finish up, just know that the test won't necessarily look exactly like the review. These are some types of questions, all right? That doesn't mean that will look exactly like that. So as we go, I will try to also say, hey, be sure and look at this, or be sure you know how to do this. Just FYI on that. Okay, so 3.1 is where we had this section that we had to look for right triangles because we needed to find the slope of like a roof line or whatnot. So that's what this example is. So we have a resort has a ski mountain that is at an elevation of 6,000 feet at the bottom of the ski run. So here's your 6,000, this is elevation. So that's telling me that this is the bottom of the ski run. And then that is this elevation right here. And then the mountain has an elevation of 8,500 feet. So that's from here to here. When a skier is 2,000 horizontal feet from the bottom of the mountain. So here's the bottom of the mountain. And from here to here is a horizontal distance. The top of the mountain, so from here to here is an elevation of 12,900 feet. Okay. All right. Well, anytime you have a picture, any problem, you're going to need to find the slope. And so that means that we're going to have to find a right triangle, because what we need to remember about slope is that it's rise over run. Okay, so this says assuming the side of the mountain slopes upward in a straight line. So here's the side of the mountain. What is the slope of the mountain? Okay, so this is what you have to remember, is that slope, which we call M, is rise over run when we have a right triangle. Okay, so when you're looking at this, is there anywhere where you have the rise and the run for which you can find the slope? What would, well, 2,000 is from here to here. If we were going to use the 12,900, I would need this whole bottom. Yeah. So it's right here. Okay, so I'm going to recreate that triangle, and I'll do it in pencil since I did it in pencil up there. My numbers aren't going to look like my picture, but we know this is 8,500 and this is 2,000. So rise is up and down. So which one's your rise?
2,000.
8,500. And the run is a horizontal run of 2,000. And we always put this over 1. Calculate that. .25. So we have 4.25 feet per 1 foot. Now that's the slope. Okay, so that's for the slope. This is what we found. Okay. How far in horizontal distance? So now we're talking this way. Is the top of the mountain from the bottom of the ski run? Okay, here's the bottom of the ski run. If they call this the top of the mountain, they're wanting to know this horizontal distance right here. So if you'll notice, this creates a right triangle right here. So let me draw that. All right, so here's my orange up there. What information do I have about, or can I find about that horizontal triangle? What do I know about it?
Slope.
We just calculated the slope, right? So I know the slope is 4.25 over 1. Now, I would assume since it's asking me to find this horizontal distance that I don't have it and I can't find it. There's no way of knowing because from here to here is 2,000, but that didn't even tell me what from here to here is. So this is what we're looking for. This is the unknown, which is your horizontal run. I'll call it that. So when I'm looking at this, I have the slope, I don't have the horizontal run. Do I have or can I find the vertical rise?
Yeah.
All right, what numbers would I use to find that?
6,000 minus 12,000.
Okay, I heard different, so I heard, what'd you say?
You said the same thing.
Okay, what'd you,
You'd subtract 600 from the, 12,000.
how about 6,000?
Oh, yeah.
All right, so from here to here is 12,900. But then we're gonna have to take away this distance right here, which we know to be 6,000. So that would give me 6,900 then, okay? All right, so now what we're gonna do is set up that equation to where we can cross multiply. So our slope is 4.25 over 1. Rise is what we just found, 6,900. Run is what we're looking for, so I'm calling it HR for horizontal run, not hours. So 4.25 times horizontal run equals 6,900. So divide both sides by 4.25. And your horizontal run is equal to, give me 2 decimal places. Bless you.
$1,623.53.
And what are we talking about here? The distance is measured in feet. So this right here is what we have found, this distance from here to here. Okay, now number 3, I don't love this question because the way the wording is, it's a little bit odd, but I'm going to show you what it represents and means, and we'll just work with it. I don't believe any on the test is going to have confusing wording.
Yeah, this was confusing.
Do what?
Number 3.
What did I say?
Oh, we were talking about number 2.
We finished number 2. Number 3, I don't like the wording.
Yeah, that was confusing.
This one?
Number 3.
Oh, I know. We're getting ready to talk through it. And what I'm saying is, I don't love it. Don't expect one that's, I'm not gonna put one on a test that is kind of confusing like this. All right. At a distance of 3,500 horizontal feet, so we're going left to right from the bottom of the ski run. So what it's saying is it's going 3,500 feet this way. And we already just found this to be 1,600 and whatever, so it goes out further, okay? What is the elevation of the mountain? So what it's doing is it's extending this and this, and it is asking you for this elevation right here. Okay, so let me draw that down here. We know the slope. And what else did they give me with this pink triangle?
The run.
the horizontal run, they said was 3,500, right? So they're giving us this as 3,500, which is the horizontal run. Now, ultimately, it wants to know this full side because it wants to know the elevation, but I'm going to have to find this distance first because we already know this distance is 6,000, and I'll just add the two. So I need to find this vertical rise. So I would do my slope 4.25 over 1 equals vertical rise, which is what we're looking for, over horizontal run, which is given as 3,500. Cross multiply, what's 4.25 times 3,500? 875?
Yeah.
So that's your vertical run. So that is this right here. And so we just need to add the 6,000 feet. So 20,875 feet elevation. What I don't like about that is it talked about, here's why I don't like this question, or I don't love it. The top of the mountain had an elevation of here, and then it talks about an elevation here, but I thought this was the top of the mountain, so I won't throw one like that at you. What I'd say on this, in WebAssign and in notes, we did some that had like a ladder against a wall and the picture was already given. You know, so there were some picture problems on WebAssign. You might see something like that on the test, where the picture is given. So just wanted to add that information on there as well. Okay. 3.2, a spring will stretch when a weight is attached to it. So it's like you have a spring, you attach a weight, and then of course it's going to pull that spring down. So the length L of the spring is a linear function. So there they give me the function. Of the amount of weight attached to it. So that means my variable is W, which is weight. Okay. The length of the spring is 4 centimeters when a weight of 100 grams is attached to it. Okay, so these two numbers go together. And it is 6 centimeters when a weight of 200 grams is attached to it. Okay, so before I try to figure out what those are, I want to take a look at this and go, okay, if I'm talking about an ordered pair, what always goes first? So in this case, weight is going to go first in an ordered pair. Length is going to go second. And it appears length is in centimeters and weight is in grams. Okay, here's why I say that. So this first correlation between 4 centimeters and 100 grams, what are they giving us there? An ordered pair. This is where you need to be careful. If you come over here to write the ordered pair and you go, oh, I have 4 100. Is that going to be correct?
No.
What should go first? Which of these two numbers is the weight? The 100. So please be careful of that on the test. So this needs to be 104. And the second one is 206. And now it's asking for the slope. Okay, you got to know that slope formula to do this, right? because when we're given two ordered pairs, I need to know x1, y1, x2, y2, and the slope, which is m, is the difference in your y's, so that would be 6 minus 4, over the difference in your x's, which is 200 minus 100. And I want this something over 1. What you got?
0.02.
Okay. Now, I'm gonna go ahead and now put my labels with that, right? So we have the difference in the function. The function is centimeters, so this is length in centimeters. And this is weight in grams. Now, why do I do that? Because this is also asking me to explain. Now, what's the item we're talking about? A spring, right? Okay, so in my explain, I would say the length of the spring and then I have to know the sign of my slope, whether it's positive or negative, because what does that tell us? If it's increasing or decreasing. And so since it's positive, it is increases 0.02 centimeters per, you can say 1 gram, or you can just say per gram. So watch out for those explains. Be sure you read everything that the problem's asking for. Okay, what is the initial value? Did they give me the initial value? No. Because what do we know is true for the initial value?
Zero.
We're looking for this. All right, so I'm gonna go back to our equation, y equals mx plus b. Y is the function, and for us, that is L. M, we calculated to be 0.02. X is the variable, which is W plus B. So what can I do to help me find what B is? What am I going to use? Okay, use one of the ordered pairs. Doesn't matter which one. I'm just going to use the first one, but if you use the second one, you get the same thing. So now, in place of W, I'm going to put 100. In place of L, I'm going to put a 4. So I have 4 equals 0.02 times 100 plus B. So I get 4 equals 2 plus B. Subtract 2 from both sides, so I get 2 equals B. So this answers the question, what is the initial value? Which means this right here is a 2. Okay, so let's think through this, because then it says, hey, I want you to explain the meaning of the initial value. Okay, when what is 0? The weight. Okay, so think about this. 2 is the what? Okay, length of what? The spring. So haven't we found the length of the spring before any weight's put on it? So my explain would be the length of the spring is 2, and that's 2 what? Centimeters. So if it was all squished together, it's 2 centimeters, and then as you put weight on it, it's gonna expand. Okay, write the equation of the length L as a linear function of the weight W. Okay, well, take this from what we did above. We know L equals slope W plus B, and then didn't we just find what B was? So in place of B, I have +2. And then question 7, if the length of the spring is 5.6 centimeters, how much weight is attached? What am I given?
Function.
Okay, so this is where you need to be careful. I'm given L. So I would have 5.6 equals 0.02 W plus 2. And then we're gonna solve for W. So the first thing that we do is we move this to the other side by subtracting it. So we would have 3.6 equals 0.02 W, divide by 0.02. And we're left with W, which represents weight in grams. 180. And be sure you put grams. Okay. All right, calculators out, because. Oh, no, I don't think we need it. Well, you've already had your calculators out, but I don't think we're putting needs in yet. So, okay. So we know when we have a table, the top is always the variable, which is X. Function is Y. So I'm not gonna say function. I mean, I can look up here and see what it is based upon that. Okay. Now notice this says age in years. So this means 20 years old, 30, 40, 50, 60. Do I need to change those numbers?
No.
No, that's if we had what year it was. 1980, 1990, whatever. Okay. All right. Determine if the data in the table are linear. What is it asking you to calculate here? Average rate of change. And we always do it with the first two. So from 20 to 30. And then we do it with the the last two, which would be 50 to 60. Okay. So we would have 189 minus 200, 30 minus 20. You may have that.
-1.1.
And that, what does that tell me when I get a slope of negative? Something's decreasing, right? All right, and then we would have 156 minus 167, 60 minus 50. I'm going to assume it calculates the same. And so if it asks you to explain, this one doesn't, but we did in notes all the time, and I don't remember on the test. So yes, it's linear because the average rate of change is constant. Y'all don't forget periods at the end of the sentences. Drives me crazy. Okay, now 9, this kind of freaks some people out on the quiz. 9 says calculate their slope for heart rate as a function of age. They see the word calculate, so now they think they're going to have to calculate something different. But didn't we just find that in the average rate of change? Mm-hmm. Yeah, so slope is the same thing as average rate of change. So I know the slope is equal to negative 1.1 over 1. Now, since I have to explain it, I'm going to write what goes with it. So remember, it's the change in the function over the change in the variable. So that means in the numerator, I'm talking about the function heart rates in beats per minute. So this is beats per minute for every 1 year. That's going to help me explain this, okay? Now, what are we talking about? A heart rate, right? Okay, so the heart rate, what is that heart rate doing? Decreases 1.1 beats per minute per what? For 1 year or just per year? Okay. All right. Find the y-intercept. Okay, this is some terminology you need to know. What does y-intercept mean the same as?
Initial
All right, look in your table. Was the initial value given?
No.
No. We know that the initial value that the x variable, or in this case, it would be the t, right, is 0. All right, so we're gonna have to do it like we did with the prior. So y equals mx plus b. So this is your x, this is your y, which of course we can change those letters to be what, t and h. All right, what am I gonna have to use? I've got the slope, don't I? Isn't that what we have right here? I need to pull an ordered pair. Here's an ordered pair, 2200. Here's an ordered pair, 3189. It doesn't matter which one you choose, okay? So insert ordered pair. I'm just going to use the first one. All right, so this is your x value, this is your y value. So in place of the y, we're going to put 200. Then the slope we calculated to be negative 1.1, and in place of the x, we're going to put 20, and this is going to help us find the y-intercept or the initial value. So we would have 200 equals, what's negative 1.1 times 20?
Negative 22.
What is it?
Negative 22.
22? Okay, thank you. Then I'm going to solve for b. So I need to move negative 22. So don't subtract it from both sides. We will add it to both sides. So we get 222 equals b. All right, now they asked me to explain this. All right, so I'm going to come over here and think in terms of my ordered pair. This is the variable, this is h. So this is 0 years. So when is that in this particular person's life? When have they had 0 years? At birth, right? Okay. And what's 222 mean? Beats per minute. Okay. So you could say something like, at birth, the heart rate is 222 beats per minute. Hearts are racing because I just went through a canal, birthing canal. All right, write the equation for heart rate as a linear function of age. Okay, so we now know the slope to be negative 1.1, and we now know the initial value to be 222. So our equation is going to be function h equals slope times variable t plus initial value. And these are the only two numbers that you will put back in. So h equals negative 1.1 t plus 222. What is the heart rate of a person who is 85 years old? What was given? My variable is t equals 85. How would I write that in functional notation? H at 85, negative 1.1 times 85 plus 222. I don't know what it is. Give me two decimal places if. What is it again?
128.5.
Y'all, as I age, this example, I'm like, okay, heartbeat slowing down and down and down, eventually it's gonna stop. And I'm getting closer to the stoppage point. Okay, what is the age of a person with a heart rate of 203 beats per minute? What are we given? And our function is h. So that means when I go back to my equation, which we did in number 11, I'm going to put this number in place of h. So it would be 203 equals negative 1.1 t plus 222. All right, so since the variable t is raised to the first power, I'm just going to solve it like a linear equation. So I need to move the plus 222, so we're going to subtract it. That give me negative 19. So you might be going a negative number, huh? But we're going to divide by negative 1.1. So a negative divided by a negative is going to give me a positive. $17.27. That's good. Now I'm going to see if this makes sense in relationship to my table. Because it was 203 beats per minute. Okay. So look, as I go to the right, it gets smaller. So 203 would be over here, right? Which means an age younger than 20. So 17 makes sense in that respect. All right. 3.4. All right, now we're going to be putting into our calculator. Okay. In a table, variable, this is my x. Function, this is my y. We also know this is list 1 and list 2. Okay. So the average life expectancy for men of all races in the US is given below. This is the number of years of life expected at birth. So 0 means 0 years since 1900. Okay, so they were born in 1900. Don't look at what the life expectancy was in 1900. That's young. Life so this would be what, 1920? Look at what the life expectancy was. 1930, you would live, that's young. Okay. Plot the data points. Okay, y'all, this kind of happened in my first 930 class. If you're asked to plot, you go to y equals and make sure that plot is highlighted. Because I had someone that said, mine aren't showing up. Well, they didn't have the plot on. Okay, so if it says plot. Okay, how do we put in our data values? What do we go to? Okay, so we're going to go to stat. Now, of course, you're not going to have to write that on the test. I just do, so you'll remember 1, and then mine are already in there. If you have numbers that are in there, don't forget, just highlight the list and push clear and then down arrow. I'm not gonna do that. Don't hit delete though, hit clear. So enter these numbers. Once you get them all entered, what do we hit? Zoom 9. If you're not getting this, let me know so we can figure out what the error is. Now, it wants me to do a sketch of this. There's not a lot of room. I don't love it that there's not more room, but we'll work with it. Okay, M male life expectancy years, and then we have B, it would be years since or births, whoops, since 1900. Okay, looks like we have one here, 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 here. Kind of like that. You'll have better room on the test. Everybody good with their, get their plot graph? Okay, write the equation of the regression line. Okay, you guys, when you see this wording right here, be careful. Do not use this for your initial value, because this is not an exact linear correlation. When you see the regression line, you need to use your calculator to find the information that you need. Okay, does anybody remember what we're going to push? Okay, so you're going to go to stat. Okay, so we go to stat, and then you need to right arrow over to calc, and then what number? 4. And then we want it to use list 1 and list 2. So just start the handy dandy, enter, 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 enter. And A is our what? Slope. So the calculator tells me that the slope, which it calls A. Now I don't see where it says how many decimal places. Watch on the test. I'm going to go 3. 0.263. And B, my initial value is 49.051. Okay, so if it wants me to write the equation, I always start out with my function. What's my function letter? M equals slope 0.263 times variable, and I come up here and the variable is B. My initial value is positive, so it's plus 49.051. Now it wants me to graph the regression line and add it to your plot. Okay, so now what do I need to do in my calculator? You're going to go to y1 equals, and you're going to enter this equation. So 0.263x plus 49.051, and then what do we hit?
Zoom 0.
Nope, graph. If you already did a zoom, if you've already done a zoom, you don't have to do a second zoom. So graph, whoops, I'm going to do that all capital. Graph right here. Had we not already plotted the points and done zoom 9, if that would have been the first time, then yeah, you do zoom 0, but not when we've done that. And then they want us to add it to up here. So Looks, kind of looks like that. Okay. All right, explain the meaning of the slope in practical terms. Okay, our slope was 0.263/1, and again, that's the change in the function over the change in the variable. So when I look up above, function is life expectancy in years. This is years. And it's per one what? It's also per 1 year. And that is per 1 year since 1900. Okay, so my function, you can just look up there and say the male life expectancy, because that's what it says in the table. So the male life expectancy. And what is it doing? Increasing 0.263 years per year since 1900. All right, explain the meaning of the y-intercept in practical terms. Okay, you do need to be careful because I'll have some students that will look up at the table and they're gonna pull this as the initial value or the y-intercept because they see that 0. If this were a true linear where it had a constant rate of change, that would be true. But since it is the equation of a regression line, you want to pull it from your equation. So our y-intercept, which is the same thing as your initial value, is 49.051. And think of the ordered pair. This would be what here? 0 years. So that was that. That's talking about a male expectancy life that was born when? Yeah, this is 0 years since 1900. Okay, so his life expectancy is this. So the life expectancy for a male born in 1900, and that's because of 0 years since 1900, is 49.051 years old. That's young. Life was probably a little bit harder living conditions back then, or maybe gotten a duel with someone. Okay, use the regression model to predict the life expectancy of a man born in the year 1980. What's given? All right, now be careful on this because my variable is B. Am I going to plug in 1982 in for B?
No.
This is since when?
82 years.
Yeah, it's since 1900, so I'm going to take away 1900, so it's 82 years. So what we're looking for is M at 82 years since 1900 is 0.263 times 82 equals 49.051. Whoops, that's plus, sorry, not equals. Now I want equals. So someone born in 1982, how long would you expect them to live? Give me 3 decimal places.
70.617.
If I was born in 19 or a male That would be their life expectancy. Maybe life expectancy years. That probably is better. In what year would a man be born if he had a life expectancy? So pay attention to life expectancy of 75 years at birth. So life expectancy goes with what? Function or variable? All right, so my function is M, and they're telling me M equals 75 years old. Okay, so I'm gonna use this formula, and in place of M, the function, I'm gonna put 75. All right, so we're solving for B, so I'm gonna subtract 49.051. 25.949. And then I'm going to divide by 0.263. So B equals
98.66539924.
I think you said 5.3, so I'll do that. All right, so this is years since 1900. So that would be 1900. I'll go approximately. So approximately 1998. Okay. Okay. Take a picture of this if you want. I am also, when I get back to my office, I will scan and add this. So this is the answer to the last page.